Welcome to SPIE ARVR 2026. Carl and I are back here for another episode of Display Skeptics. The expo is, I think, where we both spent a lot of time and saw quite a lot of interesting stuff, and especially on the component side, right? CES was final product and a little bit of components. This is almost all components, raw materials, equipment, etc. So that's kind of what we'll talk about today.
Yeah, this conference is mostly about the optics and the well, it's part of Photonics West, so it's basically about electronics and optics.
Yeah.
So you'll see some display devices, you'll see the optics that go with it,
Mm-hmm.
and also a lot of eye tracking. But I didn't spend as much
Yeah.
time on that. But there's a lot of stuff on eye tracking here too.
Well, let's break it down by category. Display side, I saw a very few laser demos, despite the technical talks being almost exclusively focused on that. A lot of micro LED and a lot of micro OLED. So I'm going to dive right into kind of one of the most impressive ones for me, INT Tech. 100K nit, max brightness, micro OLED panel. And now this to me was already insane, that we have to have an OD5 filter to be able to actually see the image with the micro OLED panel. But what's really impressive after I talked to the team is that this is all single emitter layer. We're not talking about tandem or a triplet structure like some of the LG, really interesting R&D stuff. This is a single emitting layer and no micro lens array concentration.
Yeah.
That's insane. They're essentially just trying to squeeze out as much process optimization on this single layer to get as bright as they possibly can. And then they're going to have that extra runway that Sony's already hitting the wall with in terms of the MLA or SIA with the tandem architecture. Really, really impressive stuff.
You say they don't have an MLA on that even?
No MLA.
Really?
Yeah, it's crazy.
That's interesting. Yeah, it's a little bit of I'll call it no man's land. Although we are seeing some 1D. I saw a couple. We saw one at CES. I saw
Yep.
another one on the show floor using 1D waveguides.
Yeah.
If
Like
you
the
do a
InMOs.
1D pupil expanded waveguide,
Mm-hmm.
yeah, you can with those you can use a bright OLED kind of makes
Mm-hmm.
sense. But the problem is still you end up with a pretty big vertical optics as we talked
Yeah.
about,
Yeah.
and so they're more bulky. The trend now, and as we saw on the show floor, the trend is to go with 2D expanders, even with
Right.
reflective optics. All the diffractive waveguides
Yeah.
are that way. Do 2D expand because that makes for a much smaller engine,
Mm-hmm.
and so you're getting more in the glasses form factor. But if you go with the 1D pupil replicating waveguides,
Yeah.
then you end up with you can use OLEDs, and when you're talking 100K,
I think you
that
could
gets
do
to be
some,
bright. That gets to be bright enough. I mean, you're
certainly.
seeing people get moderately bright even with
Mm-hmm.
like starting with 10,000 nit
Exactly.
OLEDs. So that
So
will get you 10 more times the brightness.
I don't know
So
what the lifetime is on this, so I don't know if we're going to see 100K output nits from micro OLED anytime soon. But the big thing is that for applications like the external glasses where they use the 10K today, they're going
yeah,
to cut power consumption by 2/3 or more. It's a very, very efficient panel, and that I think is going to lead to a new form factor where you get these micro OLED display glasses that are fully untethered.
yeah,
So that'll be pretty cool. I
it'll
think
be
they're
interesting.
going to go.
It'll be interesting to see how that turns out.
Yeah.
Yep.
Plessey is the next one. We're going to switch over to micro LED. They showed some really, really impressive monochrome panels, though they talk
Yeah.
about stacking them. 10 million nit or 8 million nit
8
red.
million nit red,
Yeah.
which is very impressive because red has historically been the really hard one to
Uh-huh.
generate. Everybody struggled with red. Well, you wouldn't think so because people think of red LEDs started it all, and then it was hard to get blue and green
Yeah.
LEDs. But today, blues are the most efficient in terms of light power, going from watts to light power, then green, and then usually red is difficult. But
Yeah.
they're getting, 8 million, actually 10 million now. They were 8
Yeah.
million a year ago, and now they're saying they're 10 million nits of red. And they're saying red is almost getting to be the
Yeah.
non-problem color for them. So that's impressive.
All GaN on silicon, so 12
Yeah,
inch CMOS compatible.
yeah. They wouldn't talk about it, but we know that that Meta had invested
Mm-hmm.
and was going to acquire their output, and instead they've kind of pulled out and no longer. But now Plessey's got taken over by another group, and then they're got a relationship
Yeah.
going with GoerOptics and
Yeah,
stuff, or
yeah. They
GoerTek.
got that investment from Halio, which was a perovskite material firm, and
Yeah,
that got a bunch of money, 100 million from GoerTek to do the Plessey acquisition. It's interesting times. I mean, they definitely have a lot of capacity, right? They have a massive fab over in England. I would argue too massive for this industry at this point in time, but we'll see. And they have big ambitions, I think, especially on the optical interconnect and what they call OPUs, optical processing units. Is my opinion is even farther out. They think that in 5 years they're going to be maybe an NVIDIA competitor in reducing the power of matrix multiplication using their optical processing unit. Would love
well,
to see that.
love to see it. Yeah, the other thing is telecommunication. One of the kind of secrets in LCOS, because I worked
Mm-hmm.
in LCOS, was that the guys who made money in LCOS were mostly doing telecom.
Yeah. Not quite as interesting as the maybe lab scale demo that we saw from Smith Display, or formerly Smith Optical. The two photon emission display, infrared injection into two ends of a TIR nonlinear optical combiner, and you're essentially using those infrared photons to generate your visible light at the intersections of the TIR beams. Wild stuff, and I cannot believe it works. When Carl first told me about them, I was very skeptical. Name of the channel, but yeah, seeing the demo in person, very early days.
It's very early
Very early
days,
days.
very interesting physics.
Hmm.
People may know that when they build like green lasers, almost all your green pointer
Yeah,
lasers today use a nonlinear material. You hit it with an infrared, and then we call it frequency doubling. We've hit it with two infrareds, and you get green. But if you hit it with a little different level of infrared, that same material
right.
will give you a real red
Hmm.
or a blue.
Yeah.
So what you do is you hit it with different wavelengths of infrared light
Hmm.
to get different colors. And so in theory, they can do all the colors.
Yeah. And so
All
their eyepiece, right, is completely transparent. It is that nonlinear optical material. You don't have any diffraction grading. You don't have any louvers that you have for the
right.
geometric waveguide.
Yeah,
Completely
and those
transparent.
materials are 90 something percent, 98,
Yeah.
99% transparent. So you don't see anything. There's no way to capture light or grab light from the real world. Now, it's very lab level stuff though. We're
Very
talking
lab
big,
level.
optical benches and stuff. But they did have one that's into a little waveguide. Now there's a lot of things they've got to work on still, from the eye box, very tiny eye box right now,
Yeah.
and they say that as they go to bigger field of views, the eye box will get better and so forth. But anyway, it's really fascinating
It's
science
cool
as
to
it
see.
goes.
Yeah, and it's cool to see a new display technology. It's not every day you see one that may actually come around to being in production in 5 to 10 years.
Yeah, another one in that vein I wanted to mention real quick is Gixel.
Mm,
They're a German outfit,
yeah.
and they've got a way of what they call eye box. They're doing an eye box steering. They're literally in a kind of a fluid. They're able to use they're basically able to steer these mirrors, these
Hmm.
micro mirrors, and they're able to basically move these mirrors in such a way that they can move the pupil around, or the light output around. So you don't, instead of having a big eye box, the idea is to steer all the light into your pupil.
Hmm.
Because if you think about it, if you've ever seen somebody wearing like really bright displays, you'll see the entire eye box around their eye. It
Yeah,
fills almost the entire eye cavity usually. And you think about it, all that light that's going around your eye is
that's
totally out the
wasted.
window. So it's another one of those ones that's very lab. I've seen
Hmm.
it work. It does kind of work. It's not perfect at tracking and stuff, and we'll see if it works,
Yeah.
if it works out. But it's another one in that film area of it's real interesting
Hmm.
kind of scientific work.
Keep an eye out,
Yeah,
basically.
something interesting, but
Yeah,
it's still at the lab level.
yeah. I would say those are the big three that got us interested. Now, on the eyepiece side, there's a big focus on geometric. But I'll start with diffractive, GoerOptic, right?
Yeah, GoerOptic, well, star there was the fact they had two silicon carbide waveguides,
Hmm.
one that was 30-degree field of view and one's 50-degree field of view. Now
Hmm.
they're very engineering prototype. It's the first time I've seen in public a silicon carbide waveguide. I mean, the image quality was not very good. I mean, it's a single. I've yet to see a wide field of view diffractive
Hmm.
waveguide that didn't have really bad color variation
Dispersion across
problems.
the entire field
Yeah,
of view. Yeah.
dispersion across. So it was not very good image quality, but it's impressive. We're still looking at basically, it's impressive that they're showing basically a
Yeah.
lab prototype there, and it's like they said it was more or less hot off the
Right.
press. So
It's the worst it'll
I,
ever
I
be.
I don't, you know, but so it's interesting they're there. I don't want to be too critical of it for something that they're willing to show,
And
but
GoerOptics
it's
has
still not at the.
every other alternative as well, right?
Oh yeah,
Etched glass,
yep,
imprinted glass,
yeah. For
you
those
name
that
it.
don't know, golly, just about every big name, every time you see a headset or whatnot,
Mhm.
every time you see a big name headset or whatever, I always trace it back to GoerOptics. GoerOptics is
Yeah.
like the brand name of making optics in China. So they're the
It's a
big
tier
guys.
one. Everybody uses them.
Yeah,
You just don't hear about them. But
yeah. They're always white labeled.
yeah,
It's always somebody else's name on the box, but
yeah,
they're the big guy for Lenovo,
yeah,
The
yeah.
Meta Ray-Ban displays were
That's
made
the
over there.
projector.
Optical engine. The
Yeah,
Loomis had the waveguide, but most of the rest of that was
yeah.
basically GoerOptics.
Now,
Or
two, I would say, reflective waveguide unique structures that I saw on the show floor were LetinAR, which wasn't quite on the show floor. It was kind of a demo that we got on the hallways, but also Optinvent. And the idea here is that you take two separate injection molded pieces of plastic and you use one of them as a substrate for your PVD coated partial reflectors. Then you put those back together and you have your embedded exit gratings or expansion gratings.
yeah.
Interesting because you can imagine this will ultimately lower the cost dramatically of these types of geometric waveguides.
The Omnivent is really almost like a Loomis clone. As a matter of
Yeah.
fact, they've been around for only 10 or 15 years as well. I remember them. They used to have like an external version. You'd see the slats and
Yeah.
stuff. I think they kind of were trying to avoid Loomis's patterns and stuff
Yeah.
initially. That was the sense I got. But this one's much closer. The only problem was with it, the image is not nearly as good as
Right.
Loomis does. It's a little more wavy. You can kind of see the pupils, and the image was awful far. And I don't know if that's how they were doing the
Hmm.
expansion, but it was not in a real headset. It was just a
Yeah.
single lens, and the actual exit uh, area was too far to be in
Right.
a real lens. If they put it in glasses, you
You'd go
would put your
cross-eyed
eyes
looking at them.
there. Well, you couldn't even go cross-eyed. You'd be looking, or yeah, you'd be
Yeah.
looking. Yeah, you would be looking cross-eyed at them because
Exactly.
they would.
Envision Photonics, one I hadn't heard of until today, is this Singaporean reflective waveguide maker. But they also had one 20-degree field of view waveguide that's a hybrid waveguide, whereas you have a
Yeah,
reflective input and exit grating, but then the expander is diffractive.
diffractive.
Yeah,
So that's really bizarre. I'd
yeah.
never heard of
They
anybody doing
they
that
talked about
before.
how it's a more efficient design that you don't lose as much light in the expansion grating if you go diffractive instead of
Yeah,
reflective. And so they're talking about up to 10%, but maybe somewhere between 5 to 10%, input to output efficiency.
yeah, but
Pretty
it was,
good.
and then they had like one that's all reflective, and
Hmm.
so they had reflective gratings and they had this reflective hybrid.
Yeah.
So I didn't even know that existed. But the fascinating thing of this show
Hmm.
is how many different reflectives you
Yeah.
see, also known as geometric. Some people,
Right.
Meta and Loomis call them geometric. But it's interesting how many
Yeah.
different ones we saw at the show.
Kind of on the IP side, a lot of geometric waveguides, some interesting hybrids, and a little bit of other stuff. On the equipment side, it's not really something that probably you'll see as a consumer of any of these products. But I found it really interesting just how many Nanoimprint tool makers we had on the show floor. I counted, I think, at least 10, if not more,
Yeah,
NIL tools. One of them is even sponsoring the show. That's a lot of tool makers. That's a lot of stamping that I'm not sure if we have enough capacity requirement for. More photonics. I really like these guys over in the Netherlands. They're doing very large area nano imprint
oh
lithography.
yeah,
They do 600 by 600 millimeter square panels. That's a
yeah.
lot of AR glasses all at once.
Right, and they can take like 12-inch wafers, and they
Yeah,
can do four at one time,
entire square panel. Yeah,
and or they can take a big square panel. Yeah,
yeah,
they show these things look almost like picture windows that they can do it on. They've
yeah,
been here for many years.
yep,
I don't know who uses them. I don't know whose
yeah,
products are in, but yeah, they're
yeah.
one of the bigger one of the
So
guys who's
I
always
think
here.
if we do see a lot of diffractive waveguides in the future, we're going to have absolutely the capacity to make as many of these as possible. It's really the reflective ones, like the Ray-Ban displays, that are in question.
Yeah,
I think on the metrology side, there's not much again for this audience to highlight. I really like seeing the cool robots that you put into production and actually do
yeah.
some
There's
measurements. And
always a lot of really important equipment makers. You know,
there's
Gamma Scientific,
exactly all the
Opto
ones you see
Fidelity.
behind the scenes that they're ones testing for. Hey, this is good enough quality for us to ship the product to you. And
Yeah, I
so
think. I think Radiant Vision Systems is another one I usually
Yeah.
see here. But yeah, they're basically selling to their they're here to try to sell to customers. The big problem in all these things is not making one of them. You can get your guys out with your measuring instruments and get one of them. What do you do if you're going to make hundreds or thousands? You start to need something. Testing optics is actually real tricky.
It's real hard, and it's really a time-intensive process. That's what gets you on the manufacturing line. Obviously, the tools to make them, but even if you make a million in an hour, testing a million in an hour is nearly impossible.
And making sure that you're testing them in a way where the human vision is kind of weird in how it works.
Well, that about does it. So until next time, whatever next conference that'll be,
Yep.
maybe Display Week.
Take care.
Take care.
Bye.
Bye.